Hey, welcome back to the Clojure Koans walkthrough number 18. We're looking at data types today. And look what we have here. This is the new version of Light Table. It's still in alpha, but I'm trying it out. So what you'll notice is whenever you enter a form, it's going to show you the evaluation of that form directly to the right of it. So you don't need to have a whole separate copy of the file over on the right-hand side where the output is displayed. So this is more convenient and it looks pretty cool so far. So back to the lesson for today though, we're looking at data types. And here at the very top of the file, we're presented with two different ways of defining some types. We see this defrecord and the second one is a deftype. So defrecord is declaring this Nobel record type, and it's going to have this prize attribute, and deftype looks pretty similar. It's defining the Pulitzer type again with a prize. So they look fairly similar. I guess we need to find out what's the difference. Why would we use a record or a type? So let's look at the example. Here we can see how you construct an instance of this type. So here, Nobel, with a period after it, is going to be a constructor for an instance of this record. So you need to pass the attribute prize when you're initializing this. So here we're calling Nobel dot and then the parameter piece. And that will give us an instance of Nobel, a Nobel record. And look what else you see here. You can you can access that prize value by calling dot prize. So that's like a special way to access that prize attribute of this type. So what would you think that would return? The prize that we passed was piece. So piece should be returned here. And yeah, we see that that's true. So types are quite similar. Right, so this was a def record, this was a def type. So what's the difference between a record and a type? Well, so far this looks exactly the same. We call a dot, we call Pulitzer with a dot to construct the instance of Pulitzer, and we pass literature to initialize the field. And when we call the prize accessor, we should be able to get out that prize value. All right, we got it. So far they seem quite similar, as they say. So records may be treated like maps. Now that's an interesting thing here. So if we create this Nobel instance, and here we are trying to treat it as a map, trying to get the value of the prize keyword. And I think that's actually going to work. So let's just verify that. Yeah, that does work. So that's an interesting benefit to using records, is you can just treat them like a map. They're transparent. Let's see, while types may not be treated like a map. So here, if you try to treat this Pulitzer type as a map, and we try to get the value of the prize keyword from this non-map, I think it'll return nil. So further study reveals why. Well, here we are testing if each one of these are maps or not. So we have this vector of a Nobel record and then a Pulitzer type instance. And when we call map, that should return the same vector, but it will have called map question mark on each one. So Nobel is a map, whereas Pulitzer is not. Cool. Okay, and just for fun, let's take a little look here. If we instantiate Nobel with with some kind of value, here's what we get back. Look how that's represented. Even just from looking at it, we can see that it looks like a map. And we would expect to be able to call, as we saw above, the prize keyword. And however, if we do the same thing with Pulitzer, and we pass some value, what do we get? We get this Pulitzer instance. Now this looks very different. This is like its own type. It's kind of opaque to us, whereas this is rather transparent. You can just treat it like a map. Okay, so that's an interesting difference. Now there's one more thing that's very important, which is protocols. So what are protocols? Well, we can see one being defined right here. It's defining the award protocol. And then it looks like it's defining a function for this protocol. So it's got this present function with two parameters, this instance and then some recipient. So a protocol is sort of like an interface. I define a name for this protocol, and then I define what functions or methods must be implemented. Now, the nice thing is you can implement protocols for records and for types. So here we've got this def record, and we're defining an Oscar record that just has this category field. And then after that, we're able to say, this should implement the award protocol. And here's how we do it. Here's our implementation of the present method. And again, you have to supply the two parameters. And here's our implementation of that. In this case, when present is called for an Oscar, we're simply going to print out some string. And here you see we're building up a string. It's going to pull out the category of this. And this would be the instance of the Oscar. So we can treat this as an Oscar and pull out the category of it. And here's the recipient variable that's passed as an argument to the present method itself. So we kind of see how that works. And let's skip over this Razzie instance temporarily. And let's see what they are asking us to do. So either sort of data type can define methods in a protocol. And we saw that. So let's see what's going on here. Here we've got an instance of Oscar. So it's instantiating an Oscar, initializing the category to be best picture. And then it's calling the present method on that and passing a parameter, evil alien conquerors, as the recipient. And remember, when we called present on an Oscar, we're going to be printing. We're going to be printing a string to the system out. And Clojure has this nice little macro here called without string. And what that's going to do is temporarily bind the console out stream to just a string builder. So it'll build up a string of whatever's being written to the console out by the code contained in here. And in the end, it'll simply return back whatever string got built up. So that's kind of a pretty cool way to be able to see and test what got output, what was output. So here in this case, we know that when we call present on an Oscar, it's going to call this function here, and it's going to print out some string. So let's build that string here. That will say congratulations on your, and then it's going to pass the category. And what's the category here? It's best picture. And then it's going to say Oscar, comma, space. And the recipient, which is the second parameter, evil alien conquerors, and an exclamation mark. And there we got it. So surely we can implement our own by now, right? So we need to call present on this RASI type, and it needs to return this kind of a string, or actually it needs to print this kind of a string, since this without string is returning whatever was printed. So here again, we've got this deftype for RASI. We're defining the RASI type with just a category as a field, and it is declaring that it is implementing the award protocol, just as the Oscar did. So we have to implement the present function, and these parameters can be named arbitrarily, but here, just out of convention, I guess, you probably want to call this first one this, since that's going to be the actual instance of the RASI. So now let's see, what would we have to do to implement this? We know we need to print out some kind of a string, so let's just start there. And what is the string we need to build? It's "you're really the blank, comma, blank, ... sorry." So we're going to build up a string that says "you're really the," and then we need to use whatever is the category of the RASI. And here we're going to do something a little different. Since we already were instantiated with this category, let's just try to access that directly and see where that gets us. So we're going to use the category, and then we say comma space, and then we say this final destination 5, which was the recipient. And for that, we can just directly access recipient. And then what? We have ... sorry. ... sorry, period. Hey, and that one's passing. So that wasn't so hard at all. Now, protocols are really nice because they are very efficient. So RASI has implemented this protocol, and Oscar has implemented the protocol. So anytime we call present, it's going to very quickly be able to determine which present method it should call based on the type of the first parameter. So this is going to be blazingly fast. There's going to be no problem. Like you might have to think twice if you're using multi-methods. That's got some inefficiencies, but with protocols, it's very efficient and very convenient. So, well, that was a very quick introduction. If you want to learn more about the differences between records and types, I suggest you go to the Clojure.org website and check out what they have to say about data types. I'll include a link in the description below. But that should tell you everything you need to know. Okay, great. Well, I hope this was a helpful introduction, and I'll see you in the next video.